In this video, I'm going to demonstrate how to perform a Fisher's exact test. And this is typically done when we're working with categorical outcomes, usually independent groups of categorical outcomes, and we're trying to see if there's a pattern. So for example, we might want to compare male and female to either having a diagnosis or not having a diagnosis. And so it's not unlike the chi-square test for independence, but in this case, if we have less than 5 expected or observed values in one of the cells in this 2x2 arrangement, if we have less than 5 observed frequencies, then the Fisher's exact test allows us to correct for that smaller sample size within a cell, while still performing essentially the same type of chi-square test for independence we would normally. So let's say that's what kind of comparison we want to do. So we want to go to the analysis menu, find 9 parametrics, and we're going to choose the Fisher's exact test. And we're going to enter our data in by hand. So we're going to create a contingency table manually so you can see how that would be done. You could also have variables selected directly from a data set, but we're going to go ahead and enter this in manually. So in this case, a Fisher's exact test is traditionally used in a 2x2 format. And so we first want to choose what we would be considering our independent variable here. That goes in the rows. So we're gonna do sex. We're gonna do a sex comparison. We're gonna compare male to female, and then we're gonna base that upon having a certain characteristic. So we're just going to call this diagnosis. So perhaps we're looking for whether or not they have a certain type of physical diagnosis, like they have excessive laxity in one of their joints, or they have a high heart rate or high blood pressure, whatever that might be. And so we're then going to enter in our 2 categories of our outcome. So in this case, we're going to put a positive diagnosis and a negative diagnosis. So again, we can see here we've got 2 variables. We've got independent variable, sex, with 2 levels, male and female, and then we have our outcome, which is the diagnosis, as being either positive or negative. And then I'm going to go ahead and enter in some values. And you can see here we have a situation in which we have one of the cells has less than 5 actual values. So in this case, it's males with a negative diagnosis. They only have 3 values. So in this case, the Fisher's exact test would be appropriate. Oftentimes, when you try and run a chi-square test for independence, and you have this situation, Intellectus will typically do the Fisher's exact test for you automatically, but in this case, we've made the decision ahead of time. That's what we're going to do. So once we've entered in our data, we're going to go ahead and click Submit. And we're going to go to the raw output. We can see here we've got our contingency table here, our chi-square table. And we can see here that we've got the number of positive and the number of negative, and then for male and female, and then number of positive for male and female, and the number of negative for male and female. And then we're going to look at the p-value, and we can see here that the p-value is less than 0.05, so that indicates there is a statistically significant relationship between gender and whether or not you have a positive or negative diagnosis. And so we can also see the odds ratio here, which gives us an idea of the effect size, the magnitude of effect. And we can interpret this. How we interpret this is looking at the top row and the first column. So we would say then males are 5.9 times more likely to have a positive outcome compared to a negative outcome. And so this pattern is not only statistically significant, but usually if we get above a 2, 2.5 on an odds ratio, that's also considered clinically significant. So we can see here that being male is significantly associated with having a positive diagnosis, roughly 6 times greater chance of having a positive diagnosis if you're male. So hopefully that you found this video useful, and good luck using it in your own research.